Hello everybody and welcome to Taconic's webinar entitled Germ-free Study Design and Timeline Planning, presented by Frank Razzaboni from Park Bioservices. Please allow me to introduce myself. My name is Margit Wissenbach and I will be your moderator today. Before we get started, I'd like to address a few practical matters. Today's webinar will be made available to all attendees. We will email a link to the presentation to you by the end of this week. Directly after the presentation, Frank will answer your questions as they appear in the control panel on the screen. So if you have a question, please type it in the control panel. The other attendees will not be able to see your question as it is sent directly to Frank and me. If you cannot see the control panel, just single-click on the single arrow on the top of your screen. In case your question is not answered at the end of today's session, Frank will respond to you within the next 24 hours via email. If you're experiencing technical difficulties, please send the host a chat message and our staff will be able to assist you. So let's get started. We hope you will enjoy today's webinar, Germ-free Study Design and Timeline Planning, presented by Frank Razzaboni from Park Bioservices. Frank's introduction to isolator technology and later germ-free technology started in the late 90s as a product coordinator, participating in several germ-free studies. His duties in those studies largely centered on logistics. He coordinated the manufacturing and delivery of the isolators and all the supplies to a major pharmaceutical company, which conducted a gut flora study in large isolators. Frank volunteered to leak test and sterilize the isolators at the customer's facility. That was the genesis of his interest and perhaps fixation with isolation technology. In 1996, Frank started his own company devoted to isolation technology. Since then, he has been the president of Park Bioservices in Groveland, Massachusetts. With the valued input of the laboratory animal community and his clients, he designs and manufactures isolators for germ-free studies and other applications. This webinar will cover what is needed to successfully launch, maintain, and complete a germ-free or Axenic project. The presentation will be an overview covering vendor selection for the various resources and components needed. In timeline planning, the focus will be on the steps and sequence of events of a successful germ-free project. And with this, I will hand over the word to Frank Razzaboni. Please, Frank.
Thank you very much for the introduction, Margit. I will get right into the presentation. We're going to cover vendor selection, animal models, food bedding and water, testing services, shipping and shipping supplies, isolator and ancillary supplies, chamber canopy size, port design, cylinders, and alternatives. And after that, we'll get into the timeline planning part. So first of all, animal models. Today, we really have very limited commercial sources of germ-free animals, and it is really Taconic that is the only supplier commercially left. So then, in terms of other sources, we have academic institutions, we have universities, and the government. So that is it for animal models. So basically, if you can find them from those. In terms of academic sources, what I'm talking about in the government is North Carolina State has limited availability of some models. Okay, talking about food, there's a discussion about what is the proper type of food to use, what is best. So I believe that there are two major, routes that you can go. The easiest is probably autoclave, because you can do it. Most people have access to autoclaving it in-house, and the second would be irradiated. Now, I have down on the screen, you can see the ProLab IsoPro little blurb that you see on all the packages. and if you look in there, it says that it's virtually germ-free, and that really isn't adequate for doing. It's fine for defined flora. It is fine for probably 95% of all the work that's done out in the lab animal community with rodents. However, it is not sufficiently irradiated for germ-free studies. So that being the case, that people and there really are no commercial sources for completely irradiated food and bedding. So how then can I recommend it? Well, what can happen is that you can go to irradiators if you have a sufficient lot of things to be irradiated and have the additional dose added. And if anybody is interested in pursuing that, I could give you some guidelines as far as the additional radiation. But it's important to note that irradiation is cumulative, and that so if it's irradiated at so many megarads, and what you need for total sterility is X, you just have to add the additional irradiation. Again, so going back to autoclave, then it seems like that's a simple solution. However, the problem comes up that frequently the people that are running the autoclave and controlling the autoclave are not fully aware of what's needed in terms of the cycles. So it's very important to coordinate with them and make sure that the cycles are the proper cycles that you need for total germ-free work. So bedding. There's a variety of products out there that come pre-sterilized. It's usually electron beam sterilized, corn cob, the paper products, and wood. In terms of recommendation, my personal recommendation with Isolators, I really like the paper products because it has the lowest amount of dust, and that is very helpful in keeping the filters clean and not blocked, and just reduces your cost a bit, I feel. The second best is aspen shavings, which is a very clean, very relatively dust-free. So we get into the others that are commonly used. Corn cob is probably I think the dustiest and the worst alternative. You also have extruded paper products, and by the extruded, you have some paper products that look like just little tiny squares. Those are fine. But with the extruded product that I'm talking about, it is gray in appearance and very fluffy. That tends to get aerosolized, and it gets up into the filters and blocks the filters a lot sooner than is ideal. So that's what your typical vacuum pack food and bedding looks like. In the lower right-hand corner is your typical Purina irradiated diet. The top, the white package at the top right, I'm not really sure what that is. I believe it was just what we would call setups. So things like paper bags, miscellaneous supplies that you need in the isolator. And to the extreme left, you have electron beam sterilized aspen shavings. The aspen shavings are really quite a nice product for using in the isolators, and the way they come prepackaged is really ideal, because I would say that the electron beam sterilized stuff that's available is probably sufficient for germ-free. The one caveat I would say is that you can't rely on just the manufacturer's claims. You have to do your own validation. So, but the packaging at least is very nice, because you can either dip it or spray it and put it in the port. Very easy to use. So getting on to water, what are the options for water? Well, currently in the marketplace, today you have your autoclave that you do in-house, where you can autoclave it in bulk, and you see the typical, I believe it's called a square pack or a French pack. The bottle at the left-hand side is 4 liters. It's one of the ways that water is autoclaved in germ-free studies. However, the problem is that it's quite heavy and very difficult to handle inside the isolator, and that's the main reason that I don't really particularly like it. The second alternative is autoclaving directly into a water bottle. The water bottles are going to be used in the individual cages. That has a lot of benefits because you don't have to handle it twice. It just goes, just put it on the cage and you're all set. The last alternative is a relatively new alternative, and that's the HydroPack. And I don't, it's something that's out there in a number of facilities. It is something that Taconic uses, although not in the germ-free area yet. But it is a sterile product. It's prepackaged water. It's pre-measured. You just put it in the cage and basically you attach the valve, stick it in the cage, and that's it. So it seems like a very nice alternative and very reduces labor considerably. So testing services, and why I'm bringing up testing services is that probably unlike a lot of things that are done in typical lab animal and SPF settings, to validate the equipment and also the supplies are very important. So you have the initial sterilization of the isolator. Typically, one of the things that I recommend for that initial setup is to use Clydox. Another alternative is to use peracetic acid based sterilants first, so something like Spore Cleanse. One of the things I think is a very good thing to consider is doing an initial sterilization and then doing an identical sterilization using a different product. Just gives you complete assurance that you've killed everything. Some products tend to work better on particular agents than others. By using two different products, two completely different types of products, like a chlorine dioxide and a peracetic acid based, gives you that absolute assurance. Again, something you wouldn't typically do for isolators if you're using them for defined flora, for like nudes and skids. You typically wouldn't use it for quarantine, but in a germ-free setting, it's much more important to get it right, get it perfect. So then, how do you just sterilize it and take it on faith that it's sterile? That's not a good idea. So what is required is to do validation. So you have things like spore strips, other biological indicators. If you have access to a bacteria lab, you could use your own broth, your own media. So that would be some alternatives. There's also going external and using external testing services where you make you buy the supplies, you collect the samples, and then send it off to a testing laboratory. One of the very important things to note is that I know in the case of Taconic, I believe I think it's a 3-week-long testing that they do before they press the isolator into service. So that means that they set up the isolator, they sterilize the isolator, they place supplies inside the isolator, and then they test by biological indicators a variety of different methods. They collect those samples, and they have to get 3 successive tests that are negative before they put animals in. So you can see that's quite daunting. You really need a lead time, and you really need to think it out. You can't really rush it. So again, your timing. I'll talk about this a little bit more when I talk about timeline planning at the end. So then, along the way, besides testing the equipment, besides testing the supplies, you also have the health monitoring of the animals. Again, if you start off and everything, they're germ-free to begin with, you have to validate along and test along the way to make sure that you've maintained sterility. So again, the same thing exists. You can do it internally if you have serology and bacteriology laboratories. If you don't, then you have to look at outside testing sources. So, in talking about isolators specifically, I like this quote from Phil Trexler. Someone asked Phil Trexler, who is basically the inventor of isolation technology in the 50s. Can you fit my project into your isolator? And Phil Trexler replied, no, but I can wrap your project in plastic. And it's really important to note that, you know, there are sources of isolators out there that have been around for years, and they're all the major producers of isolators are very good quality. And you know, this is not a plug for my products, but what you really have to look at is being able to customize the isolator to fit your particular needs. And no two projects are the same. So, you know, we can look at things like, you know, the chamber size, the port size, to get the isolators customized to what you need exactly. So, chamber size. Here, you know, when I originally started in isolators, I came from a large breeding company, and we had a particular size in mind that we felt was ideal. Well, what I found over my 16 years of experience with isolators, that it really was only ideal for them and not for the rest of the community. And so, in looking at the chamber size, you have to consider a number of different things. How many animals do you want to work with that ideal size? But also being able to house all the food, bedding, and water and miscellaneous supplies that you're going to need for the duration of the study. And where that really becomes important is when you think about it, the area that you're going to fail, you know, potential failure of a project is by having too many entries and too many exits of materials. So if you load up the isolator, if it's sufficient to, you know, to load up with all of the supplies for the entire duration of the study, that would be ideal. That might be impractical. At some point in time, you're going to have to perhaps, you know, take out waste materials, to take out any animals that have died. You're going to have to add in more supplies, but you really have to maximize, you know, get as much supplies as you can at one time, just to minimize the number of entries and exits. So here we have, you know, some extremes of sizes, both of which I feel probably aren't really ideal for germ-free work. One is a very small isolator, flexible film isolator. I think the capacity of cages there was maybe 8 to 12 cages. The isolator down at the bottom was not ever intended for germ-free work, but actually would house 330 cages. Again, not ideal for most germ-free studies, but I guess you can see the range of sizes of isolators that are available and can be customized to your particular needs. So perhaps as important, maybe even more important than the chamber size is the port size, because that's how you're going to bring materials in. And again, it may seem like I'm being redundant here, but you really want to limit the entries and exits. And so here, if we see in this picture, it's kind of an ideal picture. You have a door where you enter the supplies, but if you look to the left of the door, you're going to see a 12-inch port. That would be an additional way of getting supplies in. So you could link up a cylinder and push the supplies into the port, or you can open the door and fill the port with supplies. This is actually something that we designed specifically for Taconic, although not for a germ-free application. This is used in the IBS facility in Rensselaer. So there's the debate: why round versus rectangular? So the round port really was the first design that was used on isolators and on germ-free isolators. The round port was very handy because people were using stainless steel cylinders, and they usually came in two configurations, either a 12-inch diameter or an 18-inch diameter. And it was 12 inches by 12 inches in diameter by 24 inches long, or 18 inches in diameter by 24 inches long. And you would fill that stainless steel container with supplies. It would have a closed end, an end that had mylar that would get then butted up against the cylinder on the port on the isolator. You would tape it or clamp it in place and then push the supplies into the isolator. In the 1990s, we started to evolve a different system where you didn't need the autoclave cylinder, and we're using irradiated supplies or prepackaged autoclave supplies and just could place them into the port. So there's some real convenience issues with the rectangular port that because it's flat, it's easy to just put the supplies in, the water doesn't tip over, that sort of thing. That's a very nice feature. However, the round port still tends to be used widely because of the use of autoclave cylinders. So just two different ways of doing it. It's important to note that here we have a supply cylinder being loaded. It's not necessarily an either-or situation. Typically in the past, you either had rectangular or you had round. Now we build isolators with two ports or a port within a port, so you can have the advantages of both the rectangular or the round. But here you see a stainless steel cylinder being loaded with supplies, and that's so another alternative that we have for people that had isolators and that had rectangular and didn't have the round port configuration. We've made adapters, so you can adapt something that was made with just a rectangular door, and now with the adapter, you can link up a cylinder. Or the other use that this is used for is in the case of the Taconic germ-free shipper. You can link a germ-free shipper to this port adapter and introduce your animals aseptically. So the second part of my presentation now I'll start is timeline planning. And there we're going to talk about staff selection, discuss writing project-specific SOPs, ordering equipment, ordering supplies, and ordering animals. So, staff selection. For the people that are listening to this and are in a management role, supervisory role, in selecting the people that are going to deal with the germ-free study, you really have to look at people that have a real attention to detail. And the thing is, what are the three most important things? Attention to detail, and attention to detail. So it really can't be overstated because every step in a germ-free study is really dependent on the step before. They have to be done logically, sequentially, and thoroughly in order to be successful. So it really is a question of getting the right people, identifying the right people to do the job. SOP writing. If there's one thing that I could point to that will make a project successful, it is linked to the writing SOPs. People, I've been asked when I've gone out and done presentations about isolators, what is different about your isolators that will make it successful? We really want to get the best equipment to make it successful. And I think my answer is a bit disappointing for a lot of people. Well, it's not really my equipment that's going to make you successful. It's the procedures that you write in-house, that will make the project successful. I can help. I can, maybe point people in the right direction and recommend equipment that will be helpful. But even the most primitive equipment, going back to the original Trexler isolators, there are some of them that are still, the very original design is still being used. It's still very good. It still works. Do I think, modern isolators make it easier? Yes, of course, but they're really not the critical part of it. So the big thing that I've seen, and now because over the years of my involvement with all different types of isolator projects, I think it can be said for all isolator projects, but in particular, it's really critically important for germ-free studies, is to get the involvement of all levels. So a lot of times, investigators will buy the isolators, they'll get everything together, and they really didn't involve, fully the lab animal people. Well, the other guys that are going to be doing the husbandry, people are going to be responsible for the isolators. So if they weren't involved in the planning initially in the SOP writing, it doesn't really bode well for the success of the project, because it's very easy to leave out a step, to miss something, and that will really torpedo the project. So I really recommend getting everybody that's going to be involved with the germ-free study there on the initial meeting, and that even goes to facility people, because there are little things like controlling the traffic flow in an area where there are a germ-free study going on, so that people don't come in and inadvertently open an isolator, do something that would again contaminate the project. So can't stress it enough, and it might seem like I'm being redundant about it, but trust me, I've seen the places that have been successful. They started, and they just got everybody involved and trained everybody up right from the very beginning, and those are the people that were a great success. The people that approached it in a fragmented manner have not been successful. So just to move on. In terms of the equipment, I can tell you that for Park Bioservices, our lead time can be as little as 3 or 4 weeks, depending on a busy period of time. It can be as much as 10 weeks. And it's very important to monitor that, because no point in ordering the animals and planning your study if the equipment isn't there and in place. So the other factor is, not only do you have to, order the equipment, not only does it have to be produced, not only does it have to be shipped to you, but then you also have to consider that the things that you need to do once you get that equipment in-house. Part of that is training the people, getting the people familiar with the equipment, but then also sterilizing and then validating the equipment. All of those are very necessary steps and have to be done before the animals are introduced into the isolators. Okay. So in terms of site-specific details, it's something that comes up and is problematic more often than it really should be. There are things like very narrow doorways, very narrow corridors, elevators, that sort of thing. It's very important to map the space out and to get a feel for, first of all, how many isolators you need and how those isolators are going to fit the space, but also how you're going to get those isolators into the area. So I have a very simple recommendation on that front, and I say just make a cardboard outline and of the something out of cardboard that has the footprint of the isolator, and walk it through the corridor and make sure that it fits. Seems really silly, but I'll tell you, if people did it, it would really solve an awful lot of headaches. Narrow doorways are particularly the bane of my existence. It happens over and over again that people just don't consider how big the equipment is, coming into the area. So, and then talking about supplies, again, we talked about the vendor lead times for isolators, and then the lead time for materials and supplies can be really variable. It depends on whether or not you're going to do it internally, or whether you're going to get irradiated food, bedding, and water. You really have to consider that lead times and also leaving in enough time to test and to validate. So animals, and that's again where we come into an area where you have to monitor lead time and make sure everything else is in place, and then get the animals in. Here we see a Taconic germ-free shipper, which I've been asked over time, what's the best way. It's something that's been around since I think the early 70s, if not the late 60s. It hasn't really evolved very much, but it's an excellent design. It really works very well, and I've been hard pressed to come up with something that would replace it, that would be as efficient, both from an economic point of view and from the utility point of view. It just works very, very well, and as far as I'm concerned, would be the only way I would consider transferring animals into an isolator. And just to close, timing is everything, and getting all the steps in a logical, sequential plan in place will go a long way to make sure that you're successful. I'd like to thank everybody for their attention, and would like to open it up now to questions.
Thank you, Frank, for this very interesting presentation. So we have now, yes, we open up for the question and answer session. And please keep on typing your questions in the Q&A session box. And also remember to press the send button so we can see your question. Right, so there are a few questions here already. So what question is, what cold sterilant do you recommend?
There's really quite a variety of cold sterilants that will work. We have the chlorine dioxide-based sterilants. So there we have the tried and true, and one that I've used in germ-free studies myself personally has been Clidox. There's also MD10, that's also chlorine dioxide-based. There's the peracetic acid-based, like Spore Cleanse, that works. I'm sorry, to hop back to other chlorine dioxides, there's Alcide and ABQ. Those are very good. It seems like every year I'm seeing more and more new cold sterilants. It's just important to look at the ingredients and to see whether or not they're appropriate. One of the things I like about Clidox is that it has surfactant properties, which is that soapy, bubbly appearance that you see, and it really helps get penetration into all the nooks and crannies in the isolator, and really coats and it not only coats and kills on contact, but then Clidox also kills in the vapor phase, which makes it very, very effective. Some of the other things like VHP you can use. VHP, the problem is it only kills where it contacts. So in other words, if you had a cage and it made contact with the bottom of the isolator, it wouldn't really sterilize underneath the isolator. So I don't really find VHP to be the best alternative. Again, to do an initial sterilization and then do Clidox after that, before or after that, might be an excellent choice. But as a primary, I don't really find that to be all that effective. I do know people have used
Biosciences.
I know that people have used other things like peracetic acid and that sort of thing, and that, I'm sorry, not peracetic acid, paraformaldehyde is also a very effective cold sterilant. There's quite a list, and if somebody were interested and needed more, I could give you a complete list of the cold sterilants that could be used.
Okay, thank you very much. There is actually another question with regard to sterilant. What is the recommended contact time for the sterilant?
That really is a facility-specific thing. It really depends on what we're talking about. Whether we're talking about the initial sterilization or whether we're talking about introducing supplies and/or animals. So let me start with, we have a procedure that when we sterilize an isolator, we spray with cold sterilant, and we run the blower motor a half hour on positive, then a half hour on negative. That allows it to sterilize not only the whole isolator, but also the exhaust and intake filters. Then we let it set for 2 to 3 hours. And at the end of that, we vent out the isolator overnight. In introducing supplies, typically we have, it's typically between 20 and 30 minutes when you spray in supplies that the contact on the outside of the packaging in the port, the kill time is 20 to 30 minutes. But then you could also have a situation if you didn't use the germ-free shipper and you were introducing live animals into the isolator, there you don't want it. You couldn't take a 20 to 30 minute time, because what you're going to use is something like a Nalgene jar, a 2 liter or 4 liter Nalgene jar with a wide mouth top. You'd place the animal in that sterile container and then mist the outside, mist the port, put that into the port and close it up. and then that kind of can be as little as 5 minutes for the contact time. And that's because you're starting with a sterile container. It's sterile on the outside. The port has been decontaminated. So then you're just worrying about any contamination that's got on because the port's been open and whatever's got on the briefly got on the outside of the container. So it's a very short kill cycle when you're introducing live animals.
Okay, thank you. Another question is, what packaging is recommended for supplies?
The ideal is, and a lot of this is, comes prepackaged. You can get prepackaged supplies, whereas the level of irradiation may not be sufficient. They might have to be additionally irradiated. But the vacuum packed, food bedding is really excellent. But the things have to be, permeable but moist. If they're already irradiated, you're just gonna, it's gonna be in a plastic container, a plastic sealed vacuum packed container. That's excellent. You just have to worry about the outside of the container in that case. But then, in terms of other types of containers and ways of holding supplies, it would be the conventional way that you would have in lab animal. It would have to be something that's permeable, but then able to permeable for the autoclave, but then you can just decontaminate the outside of the packaging.
Okay, thank you. So here's a question about food. Can gamma irradiated food be used off the shelf?
No, absolutely not. There are no commercial sources, to the best of my knowledge, and it's something that I continue to monitor. There is no current commercial source of food on the market today. So you'd have to arrange additional irradiation or find someone else that has a source and share that with them, which is something that I'm trying to do for some researchers today, is to put them in contact with each other so that they can order, irradiated food if they want to utilize that method and get some kind of benefit by ordering together so that they can, send it off to the irradiator and not have to worry about doing such small batches.
Thank you. You showed several options for ports. So one question here is, what port size is optimal?
That is, it's a good question, and we used to have very specific answers in mind, and particularly my affiliation and work with Taconic has kind of pointed me in the direction that there isn't a one-size-fits-all. It really depends on the project. And I see another question that's popped up. Will the isolator suppliers help us with the design? Yeah, and that kind of, I think, goes to that question, that we'll look at what is required by the specific project, and we can help design, the size chamber that works best, the size port that works best. But we also will help with the design of the space, so we can, if we know what is available for space, we can tell you how many isolators you could fit, how you can configure the space to best fit your specific needs.
Okay, thank you. So right now there's one more question, but please, everybody, don't be hesitant. Just write your question, whatever it is, in the Q&A box. The last question I have here now is, why do you stress SOP writing?
Again, what I've seen, and it's kind of anecdotal information, the people that I've seen that have been successful with germ-free projects have very well-written, very strong SOPs, and also that involvement from all the people that are going to be doing the work. And the converse is also true. People have not been successful at people who do not have procedures in place. So it's really, over the years of experience that I've had with isolators, It's by observation that I make that statement.
Okay. Another question, what are the appropriate autoclave settings for germ-free isolators?
I don't have an answer for that off the top of my head. It's I have not really been that closely connected to the people running the autoclaves. I know there are very specific timing, cycles that are recommended. I think the folks at Taconic in the germ-free area would have a much better handle on that than I would, and we can get an answer for that question and forward that on.
Okay, right. Yes, we'll find out. So an answer will be found and forwarded to the attendee. Okay, I think there are no more questions right now. Or anybody else having an urgent question now? Otherwise, we'll also be happy to answer questions after that. Okay, then I would say thank you very much, Frank, for your presentation. Thank you, everybody, for attending this webinar. Please also have a look at our webpage. There are more webinars coming up in the near future. Several ones are related to germ-free work. So please join us again for another webinar in the near future. Thank you and bye-bye.